Thank you, Karen. So the good news about the EPR market is that it's finally decided that supporting clinicians is really important. I'm not saying that in a dismissive way, trying to be dismissive about current EPRs. I think if you go back 20 years ago when everything was on paper, then EPRs have done a great deal to try and provide a digital mechanism for hospitals to understand who's in the hospital and to take care of them. But there seems to be a consensus of self-deprecation really around the EPR at the moment. All of the press, but actually all of the suppliers as well, are coming out and saying the next generation of EPR needs to support clinicians better. And people tend to be quite focused on user-centric design as a thing that the EPRs aren't doing particularly well at the moment. And I'm making sweeping generalizations, and I apologize for those. I'm not intentionally trying to pick out one or two areas of either poor or great performance in the EPR story. I'm really just picking up on what the market is saying, whether it's the people from NHS England and NHS Digital directly, or whether it's the broader press and so on. So this point about user-centric design is quite interesting because you've got to figure out what user-centric design actually means. Because the thing I would suggest it doesn't mean is forms that have less fields on them or forms that perhaps may be tied to the workflow a little bit better. And I think the fundamental approach that we are bringing to the table for that is a little different really. And it's around the fact that the EPR should not be a tool for retrospective entry. It should be a tool for managing patients in the moment. And that is, I think, the only way to get the EPR to be something that is broadly adopted by clinicians, so that in everything they do, the EPR is supporting them doing it, as opposed to everything they do, they go to a PC at some point later and annotate the fact that they did it. So what that brings into question really is, so I'm going to give the video guys a challenge and move around a lot. What that brings into question is the concept of real time. And real time is a massively overused word. So I'm going to spend quite a bit of time trying to define really why we think it's important for today's hospitals. So these are the things that I'm presuming there's no one's going to read that list and think, I don't have that as a challenge within my hospital. These are fairly generic statements around the conversations that we see happening in hospitals, the conversations that we are having with hospitals. You know, what's my bed state? What do I have to do to get the patients who are in ED that need a bed into a bed? Those are key patient safety challenges. They're not just flow challenges, they're patient safety challenges. Preventing death from sepsis, preventing deterioration in a hospital, managing patient fluids, actually managing patients' fluids, as opposed to recording them after the fact. All of these are the things that the conversations we hear happening when we are having conversations with hospitals. And on the right-hand side, we've got the HIMSS model. And HIMSS is a fantastic starting point. There's nothing on there that you could look at and say isn't a good idea. It's a great idea. But I don't think that meets these challenges. And that's the problem that we're faced with today. The challenges of the NHS have adapted so significantly over the course of the last 5 years, definitely, 10, 15 years maybe, that the technology needs to keep pace with that. So it kind of sounds like it shouldn't be that hard, really, to take a system and make it real time. But it is technically extremely challenging to do that. And so when you look at the market of systems that have been built over the decades to be static systems, to be retrospective entry because they're PC based, they tend to make some design decisions. And this is a very generalized statement. Not everyone's systems are going to be like this. But people were led to things like putting complex stored procedures in the database. I apologize for the clinicians that some of this is quite technical in terms of terminology. using things like fat clients. So the problem with this architecture is the intelligence is all over the architecture. So the database knows things that nothing else knows because the stored procedures make decisions at the time of writing into the database. It's very difficult to take something where the intelligence is all over it and make the intelligence sufficient that it can flow to all of the right people all at the right time. So for real-time systems, you really need to keep the client thin. You don't want the client knowing stuff that somebody else needs to know because it's hard to share that information in real time. You don't really want the database making decisions. You want it to just be fast and transactional. So the point here really is that actually to get the UX design right, if real time is your requirement, is no easy task if you've started in the wrong place. And so it's going to take some time, even though all of the EPR suppliers are out there saying that this is what's going to be important to us. And even HIMSS, there was a HIMSS article released earlier on this year about the need for HIMSS to keep pace with what's changing in the market. So I picked out 3 things that we have done within our technology stack to focus on real time. I wanted to try and show how the technology is supporting clinicians in a way that is really quite complex. And one of the things is just about not having a refresh button. Refresh buttons on PCs are reasonably dated technologies anyways. But refresh buttons on mobiles just have never existed. No one's ever got a mobile phone out and looked at the data and thought, oh, I know that's old because I haven't hit refresh recently. So in order to get an estate of several thousand mobile devices, all to be able to update instantly, so that if I'm sat beside a patient and someone else is sat by the patient, when I make an update, their phone updates at the same time, is architecturally quite hard. And we've done that at scale by building this scalability layer. So any change that happens, regardless of whether it happens on a PC or on a mobile, flows through the network and flows to every device that is subscribed to that patient. So if I'm looking at a patient, I get every change the second it happens. So this is really important for us. I think you get a usability feel of using Nervecentre that is really fast to use. And clearly that's architecturally something you've got to build in from the start. The second thing I wanted to touch on, and this is something that actually I look back and think we've done a very good job on over the time, really. We made some really good decisions quite early on around lists. Lists being really important to a hospital. They're almost the core to everything you do, really, is around a list of patients, whether it's an on-take list, list of sick patients, list of patients on fluid balance. And we've done some fairly clever things that we've enhanced significantly in version 5 around managing lists. And that is, we've got this layer. So how we do this is new to version 5. We've got this layer that sits between the application and the database. And that layer allows you to effectively create a query. And you'll see this is through the demos. Today's about demos, by the way. There's 1 or 2 short presentations like this, but it's fundamentally going to be demos. So you can see I've created a query here that says patients in medicine that are not in the discharge lounge that are going home today. So we have created that using a nice user interface that's very easy for people to use. At the point that query is created, it inserts it between the application and the database. So not only does it give me the list of patients, but every single thing that happens in the system, that query gets reviewed for. So at every single second of every day, we know all of the patients that match that query. And we're able to act on that in all kinds of different ways. It's how we manage the clinician-patient attribution. When we have something that we want someone to do, we understand how to give that task to that clinician because of the list that the clinician uses. But if that list needed to be refreshed by going to the database and saying, give me all the patients on Ward B now, then we would never be able to manage it in that way. Live flow that you'll see quite a lot of, we've enhanced live flow quite a lot in version 5 too. So there's some really good things that we've done in order to do that. And when we actually added command and control to Nervecentre, it wasn't really that big a deal for us. And the reason it wasn't that big a deal is because the architecture already knew everything that it needed to know, and it flowed the information around the system in real time anyways. And you'll see how some of those things transition. Most of the demos today are going to be very clinically focused. Hence the reason for me being a bit more technical at the start, but also trying to pull out some things that you need to look out for in terms of when you see Vicky and Debbie as they're running through some scenarios, you'll see how when one person changes something, it automatically changes everywhere. Some of those things are quite important details, really. And then the third real-time feature, which we use a lot and makes a big impact, is alerts. Whether you want to call them alerts or alarms or any other terminology that you use, the ability for the system to proactively reach out to a doctor, nurse, or clinician of any type and give them the information they need and pull them into the process so that the system can run processes instead of the system making information available so that people run processes. And sepsis is a great example of this. When you see the sepsis demo later, you'll see how the system is coordinating a set of actions that need to happen across the hospital. Our system is infinitely capable of managing processes across the hospital, but they take time to figure out what the process is and who needs to do what. So sepsis is a good example, but bear in mind it's just configuration for us to do that. Sending alerts to people is really complicated. The actual sending of the alert, though, is actually really straightforward. We all get emails. We all get notified when we get an email arriving in our phone. We all know that bit isn't too hard. But if you've got 3,000 people logged onto a system, say 2,000 nurses, 500 doctors, and you want to send a notification to somebody, you have to know who to send it to. You have to know the appropriateness of that alert in order to manage that correctly. You have to know whether it's daytime or nighttime processes you're invoking. If CCOT only on 8 to 8 or a Monday to Friday pattern, there's no point in escalating to CCOT on a Sunday night if they're not working. All of those things have to be in there to appropriately manage alerts. And therefore, we feel it's something that needs to be really built into the EPR. It's very difficult to make that an adjunct to the EPR when the system has to know all of the nurses and doctors that are logged on and what they're doing. There's a few things about it that get really complicated. So I could be a nurse working in Ward B, but today I'm working in ED as a shift. Well, I still want a phone. I've still got my same username. I'm going to log on to the system in the same way as I did yesterday when I was working in Ward B. So how does the system know to route tasks to me now I've got a different persona for the day? All of those things we obviously solve, otherwise I wouldn't be talking about it. But all of those things are really important for this to be successful. People talk about alert fatigue. Alert fatigue is receiving the wrong kind of information inappropriately or insufficient information appropriately. Nobody is fatigued by being told exactly the information they need to know when they need to know it. So that was trying to cover off real time, really, and I tried to cover off there the flow of data to people, the ability to pull people into workflows, and the ability to maintain information in real time. And you'll see that throughout the course of the day. In terms of delivering that capability, we've also delivered it at really, really high scale. We've got 2 of the probably 5 or 6 biggest hospitals in the country that are strong users of Nervecentre. These are numbers from one hospital, Nottingham University Hospitals, some of who are here today. And just to call out some of these numbers, really, there are 8 accesses to data per second. So every second of the day, there are 8 accesses, 8 individual people across Nottingham accessing data. That translates to 600 database accesses per second that are happening within the system. There's been just shy of 10 million observations in around 3+ years. But that is 8,500 observations taken a day, which is one observation set taken roughly every 10 seconds across the hospital. 28,000 clinical notes are entered every single day in Nervecentre at Nottingham at one hospital. 700 escalations per day, roughly, 130 therapy referrals per day. This is a nurse beside a patient referring to dietitians, referring to physio. I think they've rolled out a few more referrals recently as well. So the numbers here are really big. And again, I obviously put this slide up with a point. The point I'm trying to make is there isn't an EPR and an adjunct beside it that's doing some quite nice to have functionality that the clinicians like. This is key system level architecture and key system level performance. And feel free to ask any of the guys from Nottingham how quick the system is at performing while it's running this level of data. They'll give you a very accurate reflection on it. In terms of what we're going to show today, and again, I'm not going to focus on this slide very much because this is going to be the focus of the demonstrations, but this is what we have developed in the last 18 months. Fluid balance is an interesting one. This is version 3 of fluid balance to us. We kept struggling with the problem we were trying to fix, which was not about replacing paper, but about preventing deterioration from mismanaged fluids. So we think our fluid balance solution is really strong now. And we've put a lot of effort in. We were supported by a number of trusts with a pilot last year, which again caused us to rewrite quite a lot of the capability there. Order comms, fully mobile. ECGs, fully mobile. Care plans, fully mobile. A full outpatient clinical noting solution. We're still at the moment going through the ERS process of accreditation. So we'll add that in hopefully later this year whenever the process finishes. We've enhanced the business intelligence capability significantly, and we've added support for DM&D for certain medication managements on our route to being a full medication management solution at a later date. So that's the capabilities we're going to talk about. We also think there's a different deployment strategy that needs to happen. The deployment strategy that is used by trusts at the moment seems to be one of two things. There is a very expensive, big bang, spend 3 years thinking about it, what people call an EPR strategy. And then there is what people call a best of breed strategy, which is making things better as they go. So these strategies, the traditional EPR strategy has a long time to benefit because actually, I don't want to put numbers on the table and be specific. There'll always be people that think the number should be bigger or the number should be smaller. But it takes a considerable period of time from completion of procurement, which, by the way, can take a couple of years as well, before any of the benefits have a chance to materialize because there's nothing actually being deployed yet. And then, of course, go live, you start to leverage the clinical features. Some people go through phases of stabilization, depending on what you've gone live with and how much disruption it's actually caused. But let's assume that's a kind of static leveraging of clinical features. The question really is why this line can't happen there. What is the reason why I can't start leveraging clinical features on day one? There really is no good reason why that shouldn't happen. We're not in 1980, 1990. You don't have PAS systems which are paper-based. You know who's in the hospital. There are some challenges with that technology that needs to be replaced, but it is sufficient to use to drive quite a lot of behaviors. And of course, that whole period then allows you to engage clinically, because if you start clinically, you'll get good clinical engagement from day one. So in terms of costs, which of course is the elephant in the room for all of this really, the traditional route is going to cost you an amount of money. I had struggled with these figures. I just put some reasonably indicative figures down. Everyone could argue them up or down, but hopefully the trend is reasonably well accepted. That in an EPR strategy, the first 3 years are going to be really expensive for you. You're going to have to buy software. You're going to have to pay 50, 100, 150 people to manage that process, rethink all of your workflows. So at this point here, we've spent, let's say, in the order of £15 million and got no benefit out of it. The benefit starts to kick in then, of course, you decommission subsystems, but you're still going through a stabilization phase, which is causing you to continue to spend money that probably wasn't on your plan that you put in front of the board on day one. And then you start the costs start to run down a little bit and get more to a stable fashion, and the benefits can start to total up. So as everyone knows, a EPR strategy has a payback period which is well beyond 5 years. And they start to rely on things like, well, the insurance costs will come down in year 8. How can you know the insurance costs are going to come down in year 8? The world could change so dramatically between now and then, it's impossible to make those statements, really. So these projects tend to cost 30, 50, 70 million pounds and have payback periods that are 10 years. But why can't you keep your PaaS? Why do you have to do the PaaS first? Why can't you just say, we're going to put some clinical functionality on top of the PaaS? Pretty much everyone here that works with us already has this in place, right? So you may only have EOBs, you may only have a couple of those things, but we've put in a shadow PaaS. We stay synchronized to the actual PaaS using HL7, which in all of our trusts we've deployed with, we've never had any show-stopping technological problems with doing that. You run this as a shadow PaaS. It's not ideal. Your discharges may be a little slower. It's not absolutely perfect, but it does the job to get a set of clinical functions across. But then why not start to move functions out of the PaaS into this system? So what started off as being a best-of-breed strategy doesn't have to be a best-of-breed strategy if all of the components within that breed are on a single system. And then at some point in time, the PaaS is sat there, not doing very much. You're maybe not even doing transfers in it anymore. Maybe all the transfers are done from your mobile and being moved across. So the project to decommission the PaaS becomes quite a cheap project because no one really cares about it anymore. And this project has a much different cost profile. You spend much less up front, you get much more benefits up front, and your benefits start to rise right at the start. Your costs are predictable all the way through. So from a CFO point of view, your spend and your benefit are much more aligned to each other. So in terms of things we'd like you to get from today, there's a number of points which we think are a little bit revolutionary in terms of what people's current thinking is. And the first one is the flow has to be part of your EPR. If flow is your biggest issue, an EPR it's a funny misnomer in EPR, isn't it? Because it's not really just an electronic patient record. It's your hospital management system. Why would you buy a hospital management system that didn't manage your hospital's flow when that is your single biggest issue? So flow has to be part of your EPR strategy. For that to be effective, the data in it can't lag behind reality, because if my EPR is telling me that I've got 17 beds free and I've got 2, then it's not actually managing my flow at all. So you need to think of a strategy that says, how do I move my EPR strategy from one of retrospective entry to one where the EPR is the tool of choice for clinicians, therefore the data is up to date? And we suggest that mobile is the right approach to that. We're not, by the way, suggesting mobile is the only approach to it, but it is an important tool in doing it. And the third point I want you to really think about is there 2 strategies, one's called EPR and one's called best of breed, or is there 2 strategies, one's called PaaS first and one's called PaaS last, both of which are EPR strategies? That's all from me. I can't remember who's next, Karen. You're going to have to remind me.
That's okay.
Thank you.
Thank you, Paul.